Good morning, respected judges. I am Anmol Bansal, captain of my team, and I am also a MBBS third year medical student in King George's Medical University, Lucknow, India. My teammates are Mohammad Umair, he is also a third year MBBS student in King George's Medical University, Lucknow, India, and Utkarsh Bansal, a second year MBBS student, medical student in Subhati Medical University, India. So, the title of our submission is Detection of Fiber Tracts and detecting them real time using intraoperative MRI. Our objective is to develop a modified anti-NSC antibody to stain the neurons and detect them during surgery using an intraoperative MRI. So, let's talk about NSC. What is NSC? NSC meaning neuron specific enolase. It is a gamma enolase or neuron specific enolase that is an enzyme that is in humans is encoded by the ENO2 gene. Gamma enolase is a phosphopyruvate hydroxylase, and it is one of the three enolase isoenzymes found in mammals. This isoenzyme, a homodimer, is found in mature neurons and cells of neuronal origin. The detection of the NSE antibodies can be used to identify neuronal cells and cells with neuroendocrine differentiation. Now let's talk about modified anti-neuron specific enolase antibody, which we have shown in the diagram here. Antibodies are proteins, that is, they are hydrophilic molecules, and therefore they are not soluble in lipids and cannot cross the cell membrane easily. It usually takes 1 to 2 hours for usual staining of NSC in pathology labs. Therefore, to improve the solubility and accessibility of anti-NSC antibodies during surgery for staining of the brain tissue, a large lipophilic molecule, as shown in the diagram, is attached to the tail or any other portion of the anti-NSC antibody to make it lipophilic or soluble in the lipids. However, this has one major disadvantage. As now the antibody is lipid soluble, it can also enter into non-neuronal cells. How to make it specific for neurons only? For that, we have attached a sulfur molecule in the anti-NSC antibody. According to a study by Muller, the presence of sulfur atom in methylene blue molecules has been suggested as the reason for its high affinity to neuron structures. Similarly, the sulfur molecule can also be attached to the anti-NSC antibodies, and therefore the antibodies can be made specific so that they are taken up only by the neurons. Now, it is also intended to attach a D2O molecule. The D2O molecule has oxygen 17. Okay, the D2O molecule to the antibody so as to use it as a contrast to enhance detection by the MRI. The radio frequency signal in MRI is attenuated by the D2O molecule because deuterium has an atomic number of 2, and all the atoms which have an atomic number of 2 attenuate the signal in the MRI. Thus, D2O H2O contrast method can be used as to investigate the structure of the nerve fiber tracts. O17 enhances the T1 relaxation time in H2 molecules. Thus, D2O17 molecules can be used to produce a unique signal that the MRI can detect, and hence it can be used as a special contrast molecule. As shown in the figure, the anti-NSC antibody show immunofluorescence, and the nerve fiber tracts can be visualized so clearly, and hence we can do this also on the MRI. Thus, the following objectives can be achieved by this method. The cerebral tissue can be easily differentiated from the tumor tissue as the antibody is specifically taken up by the neurons. The nerve fiber tracts can be easily detected as the antibodies easily and specifically stain them. As intraoperative MRIs are already being used, there is no need of a new apparatus for the solution, and it can exist with the coexisting modalities we have and that are currently under use. As the solution does not harm or remove the investigated tissue from the tumor site, it is a non-invasive solution. The procedure can be repeated as and when required during surgery and is not limited by any constraints. The only constraint that can be encountered are related to the mass of the NSC antibody absorption and its absorption rate, and that can be addressed by attaching a large lipophilic molecule to the antibody. So now let's talk about the steps of the solution. The steps of the solution include craniotomy and exposure of the site. First we expose the brain site, and then we introduce the antibodies or pour the antibodies over the tumor margin. We allow the antibodies to absorb in or diffuse in the neurons and get absorbed. So it constitutes the diffusion time. Then we do MRI of the patient intraoperatively, and the MRI detects the signal and forms an image, and thus we detect the brain fibers. Now we talk about the other options that were evaluated during the course of this solution. In first solution is use of modified gamma camera. In the modified gamma camera approach, we intend to modify the gamma camera as such so as to increase its resolving power, and hence special resolution can be obtained. The gamma camera can be used as a stylus to detect the neurons over the tumor margin. We can increase the resolution by altering the dimensions of the collimator, as can be seen in this diagram, and distance from the source. The distance of the source can be reduced to a very little extent, as we are actually opening the brain side or the brain surface, brain. So we can reduce the distance between the gamma source and that of the collimator. So using a special set of values of the collimator dimension and distance from the source, the resolution of the gamma camera can be reduced to 0.5 mm, but can be not be reduced further. The disadvantages of using a gamma camera can be its limited resolution, and also the use of gamma rays carries a risk of exposure to the patient as well as the operating surgeon and the medical staff. Our next option was use of a radiolabile substance to treat the brain fibers, in which a radiolabile substance could be introduced into the patient preoperatively that would be neuron specific. During surgery, the tumor margin could be planned into several small sections like that of a Rubik cube, onto which a directed and precise beam of X-rays would be directed. The X-ray labile substance would disintegrate and release the radio frequency pulse, which can be detected, and thus an image can be formed. But this option could not be further investigated as X-ray labile substances are not available. So in the end, I would like to conclude that a solution can work. It is a simple solution and there is no special cost attached to it, and it also carries the least risk. So thank you.